Well, good evening and welcome to Kopernik Observatory. I want to welcome all of you here live on at Kopernik. Also want to welcome those on our live stream currently watching. Actually, we're going to do a little pan here. I'd like everybody in the house to wave to everybody on. Let me see. Got a new. Oh, that's all right. I got it. Okay, everybody wave to everybody on online. Okay, there we go. It's great to have you all here today. It's great to see some familiar faces and see a bunch of new faces. Who's here for the first time? Reasonable number. Okay. Who here is a member? Oh, excellent. All right. So the people who are here for the first time, just to point out that the people who raised their hand second there know something very special, and that's the value of a Kopernik membership. We are a nonprofit science center, but we belong to a organization called the Association of Association of Science and Technology Centers, and it's a consortium of over 350 other science centers throughout the country. And your Kopernik membership gets you into all of them. So you could go to Roberson, you could go to the Ithaca Science Center, Museum of Science and Technology up in Syracuse. You could go down to the Intrepid in New York City or the Franklin Institute in Philly, all for free. And you miss the long line waiting for your tickets to get in. So if you like this kind of place, a Kopernik membership is actually a great deal. In fact, I took my daughter down to the Franklin Institute, and for the two of us to have walked in and paid the regular admission price, it was the same price as a yearly membership here. So that one visit, in a sense, covered me. But anyway, for those of you who are up here for the first time, we are actually coming close to celebrating our 50th anniversary. We were actually opened in 1974. And as an informal STEM education center, we really get a chance to do a wide range of things. We are obviously an excellent observatory, and actually probably one of the best ones, public observatories in the Northeast. But we do so much more than that. We do programs for kids as young as 3 years old. Tomorrow is actually a Kopernik Kids program that we'll be doing for 3 to 6 years old. We have our summer camps. We had a great summer camp season. In fact, some of our students this summer had an opportunity to speak to an astronaut on the International Space Station as they were flying by. And you can actually see that contact on our YouTube channel. And speaking of YouTube, back in March of 2020, I think you, in fact, our last, our current speaker, tonight's speaker, Peter Klimas, was the last speaker we had before COVID, or just as COVID finally shut us down. And we said, all right, well, we'll just wait a couple of weeks for this thing to blow over. Well, that clearly didn't happen. It got to be about May, and we decided we really wanted to stay connected with our, with our public. And so we started to live stream. We have a YouTube channel called, if you go to YouTube and just type in Kopernik Observatory, you'll find us. And it's basically what we then started doing is we'd have our presenters zoom into us, and then we would turn it back around and pump it back out onto the internet on YouTube. And then in the chat window, people could ask their questions of the presenter. We would then relay that to the presenter. And that worked out great. And even though last year we started to finally open back up again and offer in-person programs, the YouTube connection was still so valuable to people that we said let's continue to do that. So we not only done our Friday night programs, but we've also done a number of observing sessions. So Comet Neowise in 2020, we did an observing session. At the end of 2020, there was the Saturn-Jupiter conjunction where the two planets were so close to each other that to the naked eye they looked like one really bright star. And at that point, we had over 4,000 people watching our YouTube stream. Just this past May, we had a live stream. Jeremy, our YouTube. Actually, here I've got to zoom over to so you can. There's Jeremy. Jeremy did a live stream of the lunar eclipse that happened in May. And at one point, we had over 25,000 people watching our YouTube channel. and people in the chat were saying, we left NASA's live stream to come to yours. We think yours is better. So I think it speaks very highly of what Jeremy does with his live stream observing. We had hoped actually this evening, before tonight's program, there's actually an ISS pass that is literally, the ISS is probably right about there right now. Unfortunately, the clouds are preventing us from leaving, going out. We were actually going to get you all to go outside, watch that. Jeremy was going to get a camera to watch that. But we'll, there'll be other passes in the future, and we'll look forward to presenting those. So Kopernik's really all about trying to plant seeds. We don't, we're not necessarily trying to turn everybody into a scientist or an engineer, but it's an opportunity for us to learn. And it's great to see a number of youth here, but it's also great to see a number of people that really value lifelong learning. And really that I think is why, well, that is in fact why we're here, is to provide people an opportunity to learn how the world works, how the universe works. Again, I talk about planting seeds, and I apologize I've told this story a few times, but for those that are new, we have a program called Girl Power Science where we're really trying to promote more women in STEM careers. And we do this twice a year, and so we'll offer these programs for girls that are in 3rd grade through 8th grade. And it'll cover, again, a science topic or an engineering topic. And a few years ago, we had an astrophysicist from NASA talk about the work that she does, looking at carbon dioxide levels, using satellite data to see, what is our carbon dioxide level and how's that affecting global warming. And then at the end, because it's a video conference, our girls get to ask her questions. And one of the questions our girls asked was, how did you get interested in astrophysics? Which I thought was a good question. I loved her answer. She said, well, when I was in college, I was an English major. But my boyfriend was a physics major. We would go from observatory to observatory. I eventually dumped the boyfriend, but I kept the astronomy. And she now has her PhD in astrophysics and works at NASA. So you never know where a seed's going to get planted. And so we are going to continue our planting seeds, and we're very, very happy to have Peter Klimas, a teacher at Vestal High School, and a very charismatic one. If you've seen some of his other presentations that are on YouTube, they're very engaging, and we're really looking forward to your talk tonight. So without further ado, Peter Klimas.
Drew, thank you. Thank you all for being here tonight. And I just wanted to start with a couple of thanks. Thanks to Mr. Drew Desker and Mrs. Kazia Mazur, who coordinated and got me in here this evening. All the people that are affiliated with Kopernik for having me. I'd also, though, like to thank Dr. David Carter. Is that guy here yet? I'd like to thank Dr. Carter because he gave me his time one day at the pediatrician's office to really sell Kopernik in these Friday night programs. And I think that this is exactly what Mr. Desker just said. You never know what influence you'll have on others, and I'm really glad that you're here listening tonight. Finally, I'd like to thank my family for loving me and supporting me, especially my unique and obscure intellectual interests. And I have my 2 daughters here tonight, Cora and Madeline. Our introductory picture was drawn by my daughter, Cora. Thank you, Cora. So I'm going to begin. I hope this is the first time ever at Kopernik, but let's begin with a prayer. To the Greek god Helios, that is the sun, and the Greek goddess Selene, that is the moon, may you shine your light of illumination upon us and allow us to peek behind the veils of obscurity. All right, what the heck am I going to talk to you about tonight? Let's get started. I gave a talk that here at Kopernik, and I called it Astronomy, Mythology, and the Keeping of Time. It's a talk that I developed over the course of my teaching career and that I do every year to every one of my classes. But the Astronomy, Mythology, and Keeping of Time talk is really about the days of the week. Now, this talk is titled The Marriage of the Sun and the Moon, but what I realized is that it is also Astronomy, Mythology, and the Keeping of Time. I haven't changed. I'm still interested in the same stuff. Now, what do I mean when I say astronomy? I mean the kind of astronomy that I like the best, which is ancient astronomy or astronomy that you can do with the naked eye. You don't need any fancy equipment. You don't need any telescopes. You just go out and you observe, and you really know the patterns in the sky. Mythology, I also, though, here would include fairy tales and folk tales, the stories of the past that are important, that have lasted. That's what I mean when I say mythology. And finally, the keeping of time refers to calendars and how people have used the astronomy to create calendars like the one we have today. And so right in the middle, then, is also the marriage of the sun and the moon. It's astronomy and mythology and the keeping of time. Maybe I need to change the name of my other talk. So astronomically, the talk tonight is about finding a way to reconcile the sun's yearly cycle. That's what I'm talking about, the yearly cycle, which is the cycle of the seasons, with the moon's monthly cycle, which is the cycle of the phases. And big disclaimer right up front, no eclipse astronomy tonight. You could have thought that this would be about maybe eclipses. The marriage of the sun and the moon may fit nicely mythologically in with an eclipse, but that's not what I'm talking about. I'm talking about those cycles and fitting them into each other. Now, mythologically, you hear the term the marriage of the sun and the moon, and I would say that the obvious interpretation would be to find a way to create a lasting commitment between two human beings, a marriage. To compromise with another person regarding your personal interests, your values, your ways of communicating, your ways of showing love, your opinions on children and child rearing, etc., 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 etc. Right, that's marriage. But I think the more correct interpretation of the marriage between the sun and the moon is that it's an attempt to create a balance between dissimilar things, to resolve paradoxes, and to find harmony in chaos, to find the cosmos in chaos, to find order within disorder. That, to me, it's a different way of thinking, mythological thinking. It's thinking in terms of the stories, but you've got to arm yourself with enough stories so that you can think properly. Astronomy, that's the scientific thinking that I think more of us are familiar with, but this idea of mythological thinking has become much more important to me. And then thirdly, the way to look at the talk tonight would be that the keeping of time is to create a calendar that is both based on the sun and the moon, a lunisolar calendar. All right, so let's get started. I got a diagram. We got the sun. The Earth goes around the sun. How much time is represented in this diagram? Shout out the answer.
1 year.
Ooh, good job. Look at that. 1 year, right? It takes 1 year for the Earth to go around the sun. That's what a year is. But you see, that's not what we really see. We do not observe the Earth going around the sun. This is not like a common understanding in ancient times. It's that clearly the sun went around the Earth, and that takes a day. So this is what you really, though, get to observe if you observe carefully over a while. You watch that sun rise and set, but you also watch that sun move across the horizon. I know I do this. Sunset is more easy for me to observe at my house. So it's not sunrise that I often watch, but it's the sunset. But I watch that sun move right across, right? And it gets to a real extreme position and it moves back. How much time is represented in this diagram?
1 day.
It's not 1 day. Anybody, just shout it out, right? How much time does this in my, right?
It's the year.
It's not the best. It's not the best. It's a year. It takes a year. It takes a day for that sun to rise and set, but it takes a year for that sun to go all the way back across the horizon to where it started. 1 year. What's a year? Everybody thinks they know. Well, it's the time to go around the sun, right? That was the first picture. But a year is also the time to complete a cycle of the seasons. And that was that second picture, that the sun gets higher in the sky, we get more sunlight, we get more direct sunlight, and it's summer. And the sun gets lower in the sky, and we get less direct sunlight, and it's winter. And seasonally is what a year is. It's important, especially if you don't live in our age where you can go to Wegmans and you can get mangoes in the middle of the winter. If you actually had to prepare for the winter, this is an important cycle to be very, very careful of so that you don't die in the winter of starvation. It's the cycle of the seasons. That's a year. But then more fancy, I could say that the time of a year is the time for the sun to return to the same position in the sky. To return to the same position in the fixed stars as we see it from the Earth. And we could use a fancy word for that, the tropical year, which really defines the seasons. Well, how long's a year? Everybody say. Ooh, yeah, I heard it, right? I heard, wait. 365 days. That was said. 0.24. But most people would say 0.25. Yeah, because we have leap years. I got a couple up here. Don't worry. Don't worry. 365 and a quarter, because you've got that February 29th every 4 years. Except you don't. You don't, sir, right?
Right on every 400 years.
In a 400, this is not the calendar we use anymore, believe it or not, but Julius Caesar instituted it in Rome, that we're going to have a February 29th every 4th year. That'll give us that extra quarter of a day on average each year. But in a 400-year cycle, the church, Pope Gregory, had this convention. They knew that the calendar was getting off with this 365 and a quarter, and so the Gregorian calendar makes it 365.2425. You remove 3 leap years in a 400-year cycle, and so instead of having the 100 leap years in a 400-year cycle, like you might think, one every 4 years, you get 97 leap years in a 400-year cycle. And this is the calendar that we use today, and it's pretty gosh darn good. But you see, the reality, the tropical year, when the sun really returns to that same position in the sky, is it's 365.242199 days. That's the reality. And so the Gregorian calendar, it's off. But just by a tiny bit, just by the tiniest bit. And so it's going to last a long, long, long time. But that's the reality. That's the best observations we have today. Okay, next section. Maybe it's so obvious that you forget, but we take our year. Here's a calendar for 2022, and we, of course, break it down into months. 12 months. Why do we do that? Because of the phases of the moon. Yeah! They're not really months, they're moonths. But that word has just changed over time. They're the 12 moonths. There's a full moon that occurs in every month in the year 2022. There's one in January, one in February, one in March, and so on and so on and so on. And if you wanted to see the dates, there they are right here. We kind of got a more astronomy chart. And you can see the exact moment of the full moons. But you can also see in this chart that there's a great mythology, there's a great folklore that accompanies those full moons. And a lot of these folklorish names come from Native American names for full moons in the different months. And here they are from the Farmer's Almanac. My personal favorite, for some reason, is the full strawberry moon. What, 1, 2, 3, 4, 5, 6, the 6th one. What month is that? June. You've been out to Owego to the Strawberry Festival? It's in June. It's that full moon in June. It's when the strawberries are getting ripe and they're ready to be picked, and they're just so delicious if you could just have them right off the bushes. But you have this folklore that accompanies the astronomy of the full moons. Let's take a little closer look, right? Help me out, participate with me. Let's take a close look at January. The full moon in January, this past January, occurred on January the, can you see it? Can you tell? The 17th, right there. Now, there's some other moons that look reasonably full, but they're the gibbous moons. You can see a little shadow on them. All right, there was another full moon on February the, let's shout it out.
16th.
Ooh, there it is, the 16th. Ready? We got the next one on March the 18th right there. It's hard to see. This graphic, it's interesting. Here at Kopernik on the screen, those gibbous moons look reasonably full. And Mr. Klimas, this annoying guy, people will say, look, there's a full moon. And I'm like, well, technically it's actually a little bit of a shadow on the right-hand side there. You know. That thing is a waning gibbous. But anyway, full moon occurs on that, in that moment at that one day. All right, let's do a little counting, because there's some transitions here. This is going to be the longest pause. How many days between January 17th and February 16th? There's no half days on this calendar, right? We'll get there. We'll get there. But on here, this is the day that that full moon occurred. How many days in between? Let's count them up. Just count them. 30 days, all right, 30 days. Now, I just, if you were watching me, illustrated the long counting where you count each day, but there's a cheating way. It's called, do you know how many days in a week? There's 7. So if you just drop down 1 to the next week, you can count 7. Can you count by 7? So you can drop down the next week 14, you can drop down the next week 21, and then you could go to 28, and then what about the next transition? Could you do that count from February 16th to March 18th? How many days?
6.
30 days. It's 30 days. It's 30 days, sir. I'm just joking. Let's do another one. You got to do more. You got to do more. Let's do another one. March 18th, March 18th. Let's count to the next full moon, which would occur on April the, shout it out. Where's that full moon?
19th.
The 19th is starting to wane. It's hard to tell. April the 16th. By the way, there's the full moon. There's the full moon. Here's some transitions. Let's count from the March to the April date. Let's do it. Count the 7s.
56.
29 days there. If we do the next one, I'm going to help you out. We got the counting game. We played it. We play. We don't need to keep playing too many times. 29 there. And if we do the next one, we got 30 days there. Sometimes 30, sometimes 29. Because the answer is really more like that 29.5 number. But what the heck is a month? Well, one definition is the first calendar that I showed you. Well, a month is like the things on the calendar. You know, we got 12 of them. They're called January. Everybody knows the months. It's a group of days on the calendar. But the months came from the moons. They came from the months. And so in terms of a month, that is the average time from a full moon to a full moon. It's the time for the moon to complete a cycle of phases, as seen from the Earth. And a fancy way to say that is that it's the synodic period of the moon. Well, how long's a month? Well, on the calendar, a month is, there's 3 options. 30, 31, oh, thank you. There, oh, and you know what? And sometimes 29, right? Sometimes 29. But the month is, we saw on our counting, there was a 29-day gap or there was a 30-day gap. Well, how long is a month? Well, the synodic month, the time from full moon to full moon, is technically 29.530588 days. If you get really exacting to that moment of the fullness of the moon, because then immediately it starts to fade, but you got to be ridiculously careful about this. Or you could just do it over a ridiculously long time and count how many 29s and how many 30s and do a very, very, very long-term average to get the amount of days between full moon and full moon. You don't need exacting equipment. You just need long durations of generations keeping record books in the archives. How many months in a year? Everybody say?
12.
Yeah, 12, of course. But how many months in a year? Well, you got to do a calculation now between my 2 numbers that I set you up with. We've got the number of days in a year divided by the number of days in a month, neither of which are very nice. And then you get another very not nice number called the number of months in a year, which is a little bit more than 12. 12.368267. That's the number of months in a year, see? All right, I've set you up. I've set you up now to hopefully see what I see. I love to read stories to my children. And the more that I've read to them, the more that I read on my own. This comes from the Green Fairy book by Andrew Lang, who has published tons of folklore, and there are 12 different colored fairy books. But this story is called The Half-Chick. There once was a handsome black Spanish hen, and the hen laid 13 eggs, 12 of which hatched normally, beautiful fluffy chicks. But the 13th, the mother knew that something was up with this one from the moment that it pecked its way out of the shell. It was a little late, and it kind of pecked weirdly, and when it came out as a half-chick, and it hopped around on one leg, on one wing, with one eye and half a beak. And right from the beginning of the half-chick's life, the half-chick was disobedient. The half-chick didn't listen to anybody. The half-chick didn't follow along with the family. And they would go out into the fields and they would come on in, and medio pollito, because this folklore comes from Spanish, and in Spanish, medio pollito is the Spanish name for the half-chicken, the half-chick. Medio pollito wouldn't follow along. And one day, medio pollito hoppity up to the mother and was like, I'm going to Madrid to see the king. And the mother's like, that's a long journey for even an able-bodied person. You know, you, medio pollito, need to stay here with the family. But medio pollito could not be deterred, and off he hoppity-kicked in his weird one-eyed, half-a-beak way. He hopped along the road. Now, very soon, medio pollito came to a babbling brook, and there was some water, and the water was getting stuck in the reeds and in the sticks that had fallen in. And the water called out to medio pollito. It was like, medio pollito, help me move these branches and move these sticks so that I can flow freely. But medio pollito is like, indeed, help yourself. And off medio pollito hopped. Next, medio pollito came to a fire that had been dying down from the night before. And the fire called out and said, medio pollito, I am about to die. Get some dry leaves and some tiny sticks and let me live again. Medio pollito, indeed, fire, you help yourself. And off he hopped. Finally, the half-chick came to a tree, and in the tree, the wind had been kind of caught in the branches. And the wind called out to medio pollito and said, medio pollito, help me. I'm stuck in these branches. Give them a shake and let me go on my way and blow. Indeed, wind, you help yourself. I'm going to Madrid to see the king. And so off this one-winged, one-eyed, half-a-beak, one-legged bird hopped all the way to Madrid, hopped in to the royal palace, and is hopping around the side when a window was open. And that window led into the kitchen, where the cook had just been tasked with making some chicken soup for the king. And he reached out his hand and he grabbed medio pollito by the neck and tossed him into a pot of water, put the lid on. Now medio pollito was over his head in water and was like, water, 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 don't cover me up. And the water said, medio, you did not help me when I needed your help. Now you are punished. And the cook had turned on the flame, and the flame started to get the water hot. And as the water started to get hotter and hotter, medio pollito called out to the fire and said, fire, fire, please, please, don't burn me, don't burn me. But the fire said, medio pollito, you did not help me when I needed your help, and now you are punished. And finally the cook came back, took the lid off the pot, it was all steaming up, and inside looked at this pathetic, burnt, charred piece of a bird and said, this will not do for the king. It's some chicken soup. And took the pot and threw it out the window. And all that steam swirled up into the air. And medio pollito got caught up in the steam and was swirling and tumbling around and disoriented and called out to the wind and said, wind, 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 right? Don't blow me away here. I can't even keep things straight. And the wind said, medio pollito, you did not help me when I needed your help. Now you are punished. And the wind blew medio pollito up to the top of the steeple of the tallest church in Madrid. And there you will see medio pollito stuck to this day with his one wing and his one eye on his one leg blowing in the wind. Thank you. Now, in terms of mythological thinking, is what I like to call it, who the heck is medio pollito? These are entertaining stories, but I always ask myself, where the heck did some of these stories come from? They're so bizarre in some sort of ways. And I would like to argue I would like to convince you tonight that, and this isn't the only example I'm going to give you, that medio pollito, the half chick, is the 0.368267. That's who medio pollito is, with 12 full, fluffy brothers and sisters. But then there's this half chick. Now you could say, well, 0.368 isn't a half. That's true, but it's kind of close. If it's kind of close-ish. It's like a piece of a chicken. It's not a full chicken. And by the way, it's the 13th one. It's on its way because people knew that there's not 12 full moons in a year. There's enough of a difference. There's an 11-day difference, by the way. And your calendar gets pretty out of whack with an 11-day off from the seasons in one measly year. In 2 measly years, you're 22 days off. You're going to realize very quickly that your calendar isn't really a year if you're going by the moons. And so medio pollito is this 13th half chick. Not like the others, very disobedient, very rebellious, doesn't fit in. That decimal point doesn't fit in. Wouldn't it be nice if it was 12? But it's not 12. It's a little bit more than 12. And the medio pollito doesn't even try to fit in. He's insubordinate to the ancient elements not being the ones on the periodic table, but water, fire, air, and earth is the fourth one, which wasn't in this particular story. But insubordinate, and it just doesn't fit in. It's the mythic representation of trying to fit the moon cycle into the sun cycle in a single year. It doesn't work. It's medio pollito. It's this annoying half chicken. It's not good for making calendars. Now, am I making too much of this story? Right? Do you believe me yet? Do you think that I'm just like, making stuff up? Well, I would just point you toward this. Okay, check this out. In the Brothers Grimm, there's a story called The 12 Dancing Princesses. There's a story called The 12 Brothers, which, by the way, have one sister. There's The 12 Huntsmen. The 12 Huntsmen is a story about a prince who has a true love, and the true love ends up getting dissed because the father, he makes a promise to the dying father to marry someone else, the reluctantly agreed to fiancé, but the true love clones herself 11 times. So there's like 12 true loves, but then there's this other fiancé that the prince doesn't really want to marry. In the book of Genesis, there's 12 sons of Jacob, but they also have a sister, Dinah. In the New Testament, there's 12 apostles of Jesus, by the way, the Son of God, followed by the 12. And don't forget about Mary Magdalene, the 13th, who also was a disciple of Jesus. In Greek mythology, there's 12 titans, there's 12 Olympian gods. Oh, but by the way, those 6 brothers and sisters, of which Zeus was at the peak of the pantheon, there's also Hades, who doesn't really count as one of the 12 in the Olympian pantheon because Hades doesn't live in Olympus with the others. Hades is the god of the underworld. So there's like this other kind of 13th one. Like, am I really just making stuff up? I don't know. I don't think I am. But I don't know if I've convinced you. We'll see. All right, let's go to the next stage. All right, next step. Let's talk about some mythological symbolism that I would describe as parts of the sun and the moon. The sun is eternal, whereas the moon is temporal. Temporal meaning of time, the sun being out of time. Because the sun doesn't change. It always shines bright in your face. The moon, though, changes its appearance over the course of the month. The moon becomes full and then becomes new. So the sun has this very immortal nature to it, whereas the moon is mortal because each month the moon dies and then is reborn again. The sun is the source of light and life. The moon is not a source of light. It is a reflection of the light. It's very different. And of course, the sun is the ruler of the day and the moon the ruler of the night, although astronomically the moon is half up during the day, it's half up during the night, but it's still the ruler of the night. The sun is not up during the night, but the moon is sometimes. Armed with that, and armed with this beautiful chart that I made here, I got those fancy numbers that I showed you. So let's go nuts with them. Start with number 1. Just look at number 1. We got 1 year. That's that number of days in the year. That then would be the number of moon cycles that I showed you how I calculated. I took the number of days in the year divided by the number of days in the moon cycle, and you get that 365 and a quarter. You get that 12.36 number, the number of moons in the year. Let's go one notch down here to, okay, let's try to reconcile with a 2-year period of time. In a 2-year period of time, you would have that many days, the 730 days and a half-ish. And moon cycles wise, you would have 24 months, you would expect, but then that extra little bit adds up to that 0.736534. Let's round off. You got to round things off. 24, what fraction is that right there? It's like a 3/4. Yeah, can we go with like a 3? It's like a 3/4. It's like a 3. It's pretty close to 3/4. You got to be ridiculously exacting. Remember, I like ancient astronomy. You got to observe it with the naked eye, and you could maybe have an uncertainty of like a day. Something's happened today. You got that day, mark it down. You know the hour, the minute, and the second. You know the day. So you got to round some things off. All right. So you got that one. Wait. Some symbolism here. The moon dies and is reborn. That number, 24 moons and like 3/4. Check this out. There is a Hans Christian Andersen tale called The Steadfast Tin Soldier. You may or may not have heard this tale before. I would like to do an abbreviated version. I gave you the full version of Medio Poeta. Let's do an abbreviated version of Steadfast Tin Soldier. The Steadfast Tin Soldier was one of 25 in the box. 24 full tin soldiers, but the tin spoon that had been used to melt down and cast into these tin soldiers, it wasn't quite enough to make the 25th one. What part of a man is that? It's like 3/4, I think. The guy's missing his leg. And so the 25th tin soldier, this is his story, the Steadfast Tin Soldier. Tin soldiers was the sound that the tin soldiers first heard when they were taken out of the box by the little kid. And this was a beautiful playroom that he was born into. And they set up the tin soldier on the big table, all these toys. And the Steadfast Tin Soldier, the one with one leg, got set up opposite, looking at this beautiful paper castle, the pinnacle of the whole table of toys. And in front of the paper castle was a paper dancer doll that was up on one leg with her other leg raised so high into the air that you couldn't even see it because it was hidden up in her dress, wearing this beautiful sequin. And the tin soldier fell in love with the paper dancer. But he just stood there, steadfast on his one leg, shouldering his musket. Now, to accelerate the story. Well, I should have mentioned, there was a piece of mirrored glass. I always found this fascinating. It was like a lake that the kids had made with a piece of mirrored glass, and they put little paper swans on it, and so it was like a reflection of things that stood in between the tin soldier and the paper dancer. Well, the night comes, the kid cleans up his toys, but he forgets the Steadfast Tin Soldier. A goblin pops out of this box and curses the tin soldier, tells him that he's looking at things that he shouldn't be looking at, and puts a spell on him. And the next day, the tin soldier gets put up on the windowsill, falls out the window all the way down to the road, gets stuck in between the pavers. Kids go out, can't find him. Some other kids come, find him, put him in a little boat, put him in the rainwater that's in the gutter. He goes down, falls into the gutter. A rat starts hassling him down in the gutter. He goes down like a gutter waterfall into the river where the paper boat collapses and melts, and the tin soldier sinks down where he gets swallowed in the belly of a fish. And there he lies. But suddenly, there's a flash of light. It's a knife that's cutting open the fish. You see, the cook that worked in the kitchen of that family had gone to the market where that fish that had eaten the tin soldier had been caught, bought that fish, brought it into the same house, cut open the fish, and was like, the tin soldier that you kids were missing, that you lost. How the heck did it get in here? And brings it back out and sets it on the table up, staring at the paper dancer again. But you see, the curse of the goblin was still there, and for some reason or another, one of the kids picked up the tin soldier and just tossed him onto the wood stove. The coal box, I think it was. That's not the same thing. The coal box. And the tin soldier began to melt. And suddenly, a gust of wind came in through the window, and the paper dancer got caught up in the wind, and the paper dancer landed right there next to her true love and his true love, and together the tin soldier melted, and the paper dancer burst into flames, and all that remained of them was that sequin that the paper dancer had been wearing. The tin soldier had been melted down into the shape of a heart. It's a tragic story. But I believe that it is a version of a 2-year moon cycle. And nobody's ever told this to me. I have no evidence to support this other than trying to convince you here tonight. I believe that this story, I mean, I do have a lot of evidence to support it. I don't have any evidences from authority, I should say. Right? I have my own reasons that I can explain to you. That tin soldier is it's that 25th guy who is like 3/4 because he's missing his leg. He's not like the others. All of the 25 soldiers, they were cast from the same tin spoon. There's something that unites all the tin soldiers. They're all the moon going through its phases over and over again. The missing leg makes him about 3/4 of a man. The soldier was set opposite the paper dancer. Now, if you know your moon, when it's a full moon, the full moon rises opposite the setting sun. So there's an opposite. There's a look across from one another of the beautiful paper dancer and that steadfast tin soldier. They're staring at each other opposite. And there's these suggestions about the reflection in that mirror that was on the table. And the paper dancer had that one leg up. The tin soldier kind of thought that they had something going between them because of the one leg. The paper dancer, he didn't know that she actually had the other leg. It was just up high. But there was this reflection of the one leg and the one leg looking at each other. The soldier descended into the belly of a fish and was reborn. The paper dancer and the steadfast tin soldier, they were united in the end. The steadfast tin soldier, I believe, is the mythic representation of trying to fit the moon cycle into the sun cycle within a 2-year period. It's tragic because it doesn't work, because it's not multiples of each other. They don't fit, and your calendar will never work in a 2-year cycle just like the one. Is this at all convincing? I don't know. Are we getting there? All right, next, let's go to something else. Let me show you something else. Back to the mythological symbolism. Astronomically, the sun is a reasonably fast mover over the course of the year. The sun moves pretty quickly through the fixed stars. The sun travels the path along the ecliptic all the way around the dome of the stars once every year. Hence, we get the signs of the zodiac, the constellation that the sun was in when you were born. The sun moves through those constellations in 1 year's time. But see, the moon is ridiculously fast. It is the fastest thing in the sky. The moon is faster by far. It travels its path around the dome of the stars once each month. That's 12.368267 times faster than the sun. It's whipping around through the constellations, whipping around, because it goes around the Earth every month. Now, we're skipping ahead to number 8, because in number 8, if you can see here, in 8 years' time, there are 98.946 moon cycles. That's a pretty gosh darn good fit. That's pretty darn close to 99, isn't it? 98.946. And the Greeks knew about this. And the Greeks called this cycle of the sun and the moon together in an 8-year period the octateris. And Greek rituals, they had requirements for festivals and ceremonies, and they included scheduling these special ceremonies and festivals on a full moon. But, you know, if you're going to have a fall harvest festival, you don't want it happening in the summertime. You want it happening in the fall. And so you got to synchronize those full moons somehow with the seasonal cycle. The seasonal festivals ought not shift through the seasons. So the ancient Greeks, they used an 8-year cycle to marry the sun and the moon. Evidence support that this system was well in place. By the 5th century BC, 8 years times the 12 moons that you would definitely expect is 96. But you've got to get up to 99 here, see? And that requires 3 extra full moons that are going to be stuck in somewhere in your 8-year cycle. The Greeks decided to do this on the 3rd year, the 5th year, and the 8th years in the cycle. They're going to do a leap year, but that leap year is not going to have February 29th. That leap year is going to have a full extra month before you're going to turn over to the next year. You're going to add in a full moon cycle. This keeps that 12-moon cycle in step with the sun over that 8-year period. Now, it's not perfect. That number is not 99. It's 98.946. But it's 1.5 days off in 8 years. That's pretty good. Yeah, that's pretty good. Only 1.5 days off. Now, that would mean that in 150 years, according to my personal calculations, you would be off by another month. You'd have to get synced up again. It would take 150 years for this calendar to get off by a moon, and you would need to take out one moon, because that number is 98.94. You're doing 99. You're doing too many moons by a tiny bit. So you got to take one out, but that would only be every 150 years. You'd have to recalibrate. You know, you'd have to have a family meeting. And you'd have to express yourself and let people know that this wasn't working out, and you have to do something about it. The Greeks also set up the Olympic Games within this 8-year cycle. The Olympic Games, right? Why do we have Olympic Games every 4 years? Well, it has to do with the octateris. The Olympic Games were held on the 8th full moon following the first full moon following the winter solstice. Isn't that neat? The winter solstice is like December 21st-ish. We today have our new year. Hooray! Right after that by a little bit. New year. The first full moon after that winter solstice was the new year for the Greeks. There's that first full moon. On the 8th full moon, which would be like August, 8th month, 8th full moon, that's going to be a better, warmer time to have the games. And then you're going to count then the next games would occur 50 moons after the first. You'd have the next games, and the cycle completes by then counting another 49 moons, and you get 99 full moon cycles total, and you're back to the beginning of the 8-year cycle, keeping that moon in sync with the seasons. Isn't that neat? 8 years. 8 years. And there's a story about this. Yeah, would you believe that? Would you believe me? There's a story. And so the story goes, it's the Greek, of course, myth, the Greek mythological story, because this is a Greek calendar choice to do an 8-year cycle, marrying the sun and the moon in the calendar. And in Greek myth, there is a story of Atalanta. Atalanta there on the right, her lover, her true love, Meleager, there on the left. Now, I took the story from that book, Heroes, Gods, and Monsters in Greek Myths. There's lots of versions. I like to read a lot of these versions before I kind of come up with my own blended version. But primarily, that's where I got this from. When Atalanta was born, it was unlucky for her. Her father, the king, only wanted a son. And he was so upset with the birth of a daughter, Atalanta, that he abandoned her on a mountainside to die. But thankfully, there was a she-bear, and the she-bear took Atalanta in and raised her and nursed her. And Atalanta was raised out in the wilderness on the side of a mountain by this bear. Atalanta became a wilderness woman, a great hunter, swift-footed, very agile. Now, in a neighboring kingdom, there was a king and a queen who had a child named Meleager. And Meleager, the prince, was not like other princes. He didn't care for all these prissy suitors that came his way. He wanted a real woman, an outdoors woman like him, that loved to hunt, that loved to go outside and be in the elements. And he didn't want anything to do with any of the people that came by suiting him for marriage. But a weird thing happened when Meleager was born. When Meleager was born, one of the fates came to his mother and told her, "The fire, when that log that's already burning on the fire is burnt, your son Meleager will die." Well, his mother was like, "Oh my God," and rushed to the fire and put water on that log. That log represented her son Meleager's life, and so she wrapped it up in a blanket and she hid it in a case and locked it away so that her son would live. Since Meleager loved hunting so much, he was out hunting, and he came across a bear, and he battled this bear, and he ended up sticking a dagger into the throat of the bear, but the bear lumbered off, and he was tracking the bear all day, and he was following the blood of the bear, when what did he see? But he saw this something coming around. It was carrying the bear on its back. It was a beautiful woman, and this woman was carrying this bear, and he was like struck by her beauty out there in the wilderness and said, You found my kill. And she was like, "Your kill? You killed this bear?" And it was then that Meleager and Atalanta met each other. And they had it out. Because that bear was part of Atalanta's family. And she came after Meleager. Now, he was not about to fight a woman. He was trying to fend her off gently, but soon he realized he needed to go full force against this woman to defend his own life. And they were wrestling, and they were going after her here. And during this wrestling match, of course, they fell in love. They fell deeply and madly in love. This was the woman that Meleager needed, an outdoorsy woman, a woman that was tough, a woman that wasn't going to take anything from him, a woman that could practically beat him up. And so he and Atalanta fell madly in love and loved hunting. Meleager found that huntress that he had dreamed of. They hunted so happily together, and they brought back so much game that word came to Artemis. Wait. That new space program from NASA is called Artemis. Where is it seeking to go? To the moon. Because Artemis is a goddess affiliated with hunting, outdoorsiness, and the moon. She made her father Zeus promise her the moon, and he was like, oh, okay, honey, I'll give you the moon too. And Artemis became part of affiliation with the moon. Artemis, the goddess of the chase, the lady of the wild things. Word came of this pair, Meleager, the handsome prince, the great spearman, and of his companion, Atalanta, so tall and fleet and strong that people were saying that she, Atalanta, was Artemis herself come to earth, right? How dare you say that? The goddess grew very angry. I'll show them there is only one Artemis, she cried. I will set them a hunt that they will never forget. And she dug her hands into the muck of the river Scamander and molded a huge boar, mud-covered with evil red eyes. And she set this boar a bloodlust, and it was huge, and all it wanted to do was kill all day. And she set it right there in the kingdom of Meleager. Now this thing started taking out goats, horses, cows, killing everything in its path, mauling people. It even got to a barn and just busted the barn. Whole thing collapsed, killing a whole bunch of people. They're trying to pull people out of the rubber. Meanwhile, there's this like rhinoceros-sized boar terrorizing the countryside. This is like the best dream for Meleager and Atalanta, because this is this is what they love, hunting. This is the ultimate hunt, to hunt the Caledonian boar. Now, this is just one of my favorite scenes. I just can imagine this this is like the best movie scene right here. I mean, this boar is taking out everybody left and right. All these heroes, all these fierce warriors coming after the boar, just like ripping legs off, ripping everybody, just throwing them over his shoulder. And finally, Atalanta gets a shot in with her bow right behind the boar's ear, all the way down to the bottom of the arrow, like up into his skull, but he just keeps charging. Bah! Another arrow right through his eye, deep in there. He keeps charging. Well, Meleager's like, no, you don't come after my Atalanta. Meleager comes out, runs at the boar with his spear, throws it right up under his armpit. I mean, he's like, oh, right. This boar is not to be deterred, keeps charging. Meleager just jumps right over this huge rhinoceros-sized boar, and before it can even turn around, he stabs it right through the hump in its back, severing its spine and killing the boar. I love this mythology stuff. So the boar is dead, and Meleager, even though Meleager kills it, he of course is like, it was Atalanta that made this happen. She was the one who got those shots in that started the kill. I finished it, but severs the head of the boar and gives it to her, the biggest prize there was. Now, nobody liked Atalanta except Meleager. Meleager's parents hated Atalanta because Atalanta was this wild woman. Their son was a prince. He needs to marry a princess. And the uncles, Meleager's mother, her two brothers, they were mad. They came right up to him and confronted him. And they said, Meleager, this is unacceptable, awarding the boar's head to her. This will not be tolerated. Meleager was too madly in love. He severed the heads of both of his uncles. When this news came back to Meleager's mother, not only was she angry about her two brothers who had just been killed by her son, but she was angry that he would have the audacity to marry this wild woman. The audacity to marry this woman. So she got out the wood. She put it on the fire, and she killed her son. Well, this devastated Atalanta. This was her true love. It devastated her. And she actually returned to her own kingdom, where she was a princess, by the way. And her father, of course, took her back in because now she's famous. She's like part of this like hunting party, killing the Caledonian boar. Like everybody knows about Atalanta. And so he takes her back in. And all these suitors come to try to win her hand, but she's not interested. She was only interested in one man, Meleager. But she's got to do something to get these men away. So she says, any man that wants to come here and marry me has to beat me in a foot race. She was the fastest woman there was. And men came, and they all were beaten by her. But the deal was that if you lost, you got your head chopped. And if you won, then you get to marry Atalanta. But her beauty, it just lured men in. Now, there was one man who had been in the hunting party of the Caledonian boar and had played really no role there. But he had fallen in love with Atalanta. And he knew it wasn't his place. He knew that she loved Meleager. In fact, he loved Atalanta so much that it pained him deeply that he knew that Meleager had been killed, because he knew that hurt Atalanta, and he truly loved her, and he cared about her feelings so deeply that he even was sad that he couldn't, the man that she loved was killed. It gave him the chance, right, to be with her, but it made him so sad. He was in love. And so he came, and he agreed to the race. He knew she was faster. But true love makes you do crazy things. And so he said, I can't be deterred. Even Atalanta thought this was a nice guy and said, you don't want to do this race. You're actually you're like one of the nicest guys that's come around. But I'm gonna beat you easily. Now this man that came, his name was Hippomenes. Hippomenes came. And Hippomenes, for all his gentleness, he could not be moved. He insisted, so the race was set. Now all the other young men who had raced Atalanta, they had prayed to various gods to give them victory. They prayed to Hermes, the wing-footed. They prayed to the god of games. They prayed to Ares, the god of victories. They prayed to Artemis, the mistress of the chase. They prayed to Athene for strategy, to Zeus for strength. But Hippomenes prayed to none of these. He thought to himself, the others want to coerce her. I want her to want me. So he prayed to Aphrodite, the goddess of love. And Aphrodite answered his prayers and gave him 3 golden apples. 3 golden apples that were so irresistible that anybody who saw them had to go for them immediately. And so the race began. This is my favorite part. We're almost there. All right, here we go. This is so good. The race began. On the race course, Atalanta, poised for the starting signal, and 100-fold more lovely, disrobed than with her garments on. The moon, revealed, 100 times more beautiful than covered up. Naked racing. She looked fiercely around her. She wondered. Wonder at her beauty took hold of all those who saw her, but most of all the man who was waiting to run against her, Hippomenes. He kept his head, however, and he held fast to the golden apples. They started, she flying swift as an arrow, her hair tossed back over her white shoulders, a rosy flush tinging her fair body. She was outstripping him when he rolled one of the apples directly in front of her. It needed but a moment for her to stoop and pick up the lovely thing, but in that brief pause, it brought him abreast of her. A moment more, and he threw the second, and this time a little to the side. She had a swerve to reach it, and he got ahead of her. Almost at once, however, she had caught up with him, and the goal was now very near. But then the third golden sphere flashed across the path and rolled far into the grass beside the course. She saw the gleam through the green. She could not resist it. As she picked the apple up, her lover, panting and almost winded, touched the goal. She was his, her free days alone in the forest, and her athletic victories were over. You ready for this? Are you ready for this?
Yes.
The race is the race between the sun and the moon. She was like Artemis herself. She was like Artemis herself. Artemis was mad because Atalanta was like a mortal representation of a moon god. And Hippomenes was swift, but not as swift, not as fast. This right here would be those 3rd, 5th, and 8th year of the octateris, where you add in a leap month. So in 3 years, 12, 24, 36, 36 moons, that would be that many days. That's the sun, Hippomenes, the sun. But Atalanta, 36 months. Now, this confused me when I made this chart at first. But think about which wins the race. Will you say the higher number wins the race? No, no, no. The lower number wins the race. It's completed its cycles before the other. It's like track. It's like swimming. It's the low number wins the race. So after that 3-year period, Atalanta's way out ahead, right? 1,063 days, that completes the 36 moons. And Hippomenes is behind, but it's at that moment that he tosses out the first golden apple. The first golden apple being the leap month in the octateris. And that sets her back, and he comes abreast of her. But if you see 1,095, 1,092, he still hasn't quite caught up, but he's abreast of her. He's next to her. I mean, 3 days out of 1,092, that's pretty darn close. He's right there. And again, she gets way ahead. 1806, now it's been 5 years. 12, 24, 36, 48, 60, that's 5 years. But you already had the one apple thrown out, that's 61 months. Atalanta's way ahead. But he tosses out the second golden apple, and this is when he takes the lead for the first time. Hippomenes takes the lead. Well, they get to the finish line, and at the finish line, Atalanta would have won. But for that third golden apple, that third leap month, that third leap year, Hippomenes just barely beats her, just barely, by about 1.5 days in an 8-year cycle. Now, there was one last piece. The last piece is that even the Greeks realized that the 8-year cycle wasn't quite good enough, that 1.5 days was bothersome after long periods of time, and that there's an even better cycle. And this better cycle was given a tribute to Meton, an Athenian, in the second half of the 5th century. The Greeks, they were aware that their octateris cycle, it was slowly getting out of step with the natural cycles. The marriage was drifting apart. The Greeks may have borrowed knowledge of this cycle from the Babylonians, or it could have been discovered independently. But way down here at the bottom of the chart, 19 years, 234.997 moons. That is ridiculously close. 235 moons in that 19-year cycle. They knew of this 19-year cycle. They got the 235 moons right. They required 7 leap years where they added in an extra month in those 7 years out of the 12. This keeps that 12-moon cycle in step with the sun. It's only 2 hours, 4 minutes and 25 seconds off in a 19-year period. That means that every about 6, according to what I calculated, 6,493 years, you gotta recalibrate your calendar. That's good enough for most people. Woo! So, to finish this evening, I really appreciate you all indulging me. That metonic cycle, that 19-year cycle, though, mythologically, what it means to me, it's that even the most wonderful marriages, they're not perfect. That there is still a small discrepancy. That there is still a need for reconciliations over long periods of time. And that fundamentally, the sun and the moon, they have different natures, and they have different cycles, as seen from the Earth, because their cycles are independent of one another. Yet, despite this independence, we humans, we have a deep desire, we even have a spiritual need to set those festivals, to embrace both heavenly bodies in our astronomy and in our myth and in our calendars. We perpetually seek to marry the sun and the moon. Thank you.
All right. Once again, just fantastic presentation. Thank you much. Let's see if we've got any questions, either here in the audience or on our live stream. So, although I will say that I think if that astrophysicist I spoke of earlier had taken physics from you in high school, she would not have chosen a literary, initially career path. Which is, and anybody here go to Vestal? Because if you do, sign up for his class. All right. All right. See, do we have any questions here? Oh, yes, right here.
So if we know the Gregorian calendar is off by that point number, even though it will work for a while, why not just change it correctly now if we know the number accurately?
So I think that the best way to change it is that you have to wait. Now, I don't know that number off the top of my head, but let's say it's like 7,000 years. What you could do is you could just wait 7,000 years, and then at one point in time, people can all agree around the world, we're going to do an extra leap day, and we'll do it, and then you'll be good for another 7,000 years. That's the way that you fix that Gregorian calendar. It's so close that it doesn't really need much fixing. It's good for super long periods of time.
But what if we just made a new calendar that's just completely separate, that is actually accurate using the number that we approximate?
So this is, yes, yeah, so restate?
Yeah, please.
Yeah, so what if we use, the question was, what if we just use a different calendar that actually did fit it instead of doing what I suggested? And I think that one of the, deep hidden in all that I said tonight was that there is no such calendar. What I just described may be the best way to do it. And that there isn't some other version of it that you really can have. There's just there are cycles that are not convenient. That wouldn't it be nice if the Earth turned around an exact number of times when it got back to where it started, but it doesn't. And so you've got to deal with this little teeny bit extra that is just the way things are.
Yep, we have a question from the live stream here from Fred Kelly asking, where do you find your material, for the stories for tonight?
So could I have some camera help? We could just show some of the materials that I brought in tonight. But this is to Fred. There's not on that table, right? Could you show the viewers at home? I brought in some of the books that I used for the talk this evening. And these are just a wide array of things. This is really just a personal interest of mine, is, as I described in the beginning of the talk, marrying this astronomy, mythology, and the keeping of time. And these stories have just interested me more and more and more. And as Mr. Desker said, take physics, but this is not really high school physics tonight. This is what Mr. Klimas finds personally interesting and explores in his own weird way over the course of long periods of time, seeking and seeking and seeking. And you can see on that table there were the mythology and the folklore and the fairy tale books, which you've just got to start reading a lot of to get what I would call even the ability to think mythologically, because if you don't know enough stories, then you can't decide what to do in a tricky situation when several people are mad, and if you do this, then you're going to anger one person, but if you do this, you're going to anger another. You need enough stories to give you advice, because there isn't always an easy answer to those sorts of questions. But then the other books that were on the table were that Ancient Astronomy book by James Evans, and the main one that I might say is look into a man named E.C. Krupp, who is the head of the, Los Angeles, that observatory, Griffith Observatory. E.C. Krupp has written a number of things that I have delved into a little bit, I've dabbled in, and he is always amazing to me. He always gets me going on new ideas that then I try to explore further.
Yep, we got one more. So Randy asks, from the data you showed, where do you, sorry, wrong one. Do the decimals stop as shown, or do they continue?
I created those Excel spreadsheets, and I used numbers that were quoted by E.C. Krupp about the number of days in a year out to the, I think it was 8 sig figs. And I used a number that he also quoted about the number of days in the synodic period of the moon. In researching this, the synodic period of the moon, when I looked it up on the internet, it was reasonably consistent. I found that same number out to all those decimal places in multiple sources. But the tropical year gave me a little trouble, and I just said, I don't know, but I'm going with this one. There was a number that was in his book. There were some other variations on that number. Now, the year is the trickiest of tricky ones because the Earth does so many weird things. You think you know what you're talking about, and then you're like, oh, okay, never mind. The Earth precesses, right, if we're familiar with this. What is that, 26,000 years? 26,000 years. It wobbles that North Pole. And that wobble, 1/26,000th each year, it sets the vernal equinox position off by just the teeniest amount. And so you have these ages, the age of Aquarius and the age of Pisces, and the vernal equinox is shifting through the zodiac very, 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 very slowly, and that affects the seasons because the Earth has to be tilted in a certain way to get the seasonal. And so this extra wobble on this very long-term cycle matters. These are also called, there's a number of these really long-term cycles called the Milankovitch cycles. And the Milankovitch cycles are the wobble. They're also a wobble of the tilt. How many degrees is the Earth tilted? 23.5 degrees. Everybody knows that, right? Well, that varies, that wiggles. And then you also have the eccentricity of the Earth's orbit around the sun, which wiggles. And so all of these things make these numbers tricky to pin down to that extra decimal point. And are they even changing over the course of time? I think they might be.
All right, you have another question? I'm going to run over here. Do my Phil Donahue thing, and I'm dating myself.
How many full moons are there in 22 years?
I don't know. In 22 years, I would have to calculate. I don't know.
And when did the year start?
How many moons?
Well, I mean,
yeah.
Because depending on when you actually started. Although it also occurs to me that I've heard recently that
Calculator.
there is some that they're talking about the rotation of the Earth is changing, and it's due to like some of the large hydroelectric dams that get built, that it actually starts to slow the rotation of the Earth around. So now we have where humankind starts to affect our rotation as well.
So I did a calculation. How many full moons in 22 years? 272.1.
And there it is. Oh, got another question?
Yes, sooner or later we're going to get 2 moons in 1 month. When's that going to be? And what do you?
Yeah, so that's a great.
What do you call it?
That's a great point. Because you have that extra little bit, occasionally that 13th moon occurs in that year. You don't have 12, you have 13. When it occurs within the same month as on our calendar, we call that a blue moon. You have those folklore names that I showed you. There were no blue moons in 2022, but I think there might have been 2 blue moons actually a year or 2 or 3 ago, if we look back. And we call that a blue moon. I think that was defined fairly recently in like an astronomy sort of magazine is like, well, what are we going to call this when we get that second one in the same month? We'll call it a blue moon. It happens once in a blue moon.
Right, any other questions? Anything else on the live stream? Oh, I'm sorry, we do have a question here. Okay.
So my high school physics teacher was strange. And his tests had interesting things in them. Do any of these things work their way into the tests that you give your students?
They do not.
Because I Googled you and I saw the ratings that you got, and your test ratings did not get a good grade.
Interesting. I have not Googled that, but I think that it is a reflection that I teach AP physics, I teach IB physics at Vestal. The tests are challenging for students, And you know, when you're trying to do something that is really challenging, you can be frustrated by it. I think that my tests are fabulously excellent, but I also think that they are very challenging, and they're very challenging for kids. And that part of being a teacher, pushing people to excel, is a great balancing act, right? I think it's a great marriage of the sun and the moon. You want to push, but you don't want to push too hard. You want to get in what right, educational theory would call that zone of proximal development, where it's not too hard, but it's also not too easy. Kids tend to love too easy.
So I know some people go into teaching, and what they take in college is a bachelor's degree in education and a master's degree in secondary education. My son went to Vestal, and he had a geography teacher who majored in geography for his bachelor's degree, and then he got a teaching degree. What's your background?
I have an undergraduate degree and a master's degree in computer engineering. It was during my time in graduate school that I realized I was not like the others. I was like medio pollito. and that I had also this other thread in my own life, which was swimming. I swam through high school. I swam at Villanova in my undergrad at a D1 program. And every summer, when a lot of my engineering fellow classmates would go back to Lockheed Martin internships and things like that, I was putting on a Speedo and getting to the pool and doing belly flop competitions and like getting pennies off the bottom on the 4th of July and dressing up for the teams that I coached swimming in New Jersey. And I loved doing that, and it was my love of coaching swimming that directed me into a very difficult decision at that point in my life. It was a real tough choice that I had to push back against everybody to say that I wanted to be a teacher. And I loved coaching, and I love teaching to this day, and that I didn't want, it was right for other people. I could tell it was right for those other people, but it just wasn't right for me.
All right. Well, I think we've exhausted our questions from the, another one back here. All right. I love it. All right. Here's your.
Is there a way to make a perfect calendar?
My answer would be probably no. Or it would be on such a ridiculously long-term basis that it's like, who cares? Now, we have I would argue that our Gregorian calendar that we use today it's good enough. It's good enough. But it's not a moon calendar. We are out of sync with the moons. Those moons, they happen whenever. They don't happen on that nice time. So the universe hasn't set it up in such a way that it's convenient for us.
All right. Well, with that, I normally at the conclusion of our programs, we would then have you go outside and look through our scopes. And my rule is you can't leave Kopernik until you look through a scope. But in lieu of that, if you paid to get in, if you go to one of our interns, they will give you a card to come back on a night that is clear. And again, if you've not been done any of observing up here, it's extraordinary. Even people who live here in the area will come up here and they're like, where did all these stars come from? So it really is, it's a great opportunity to look deep into the skies. We love showing off our scopes. Again, if you're here for the first time and you would like a tour of our scopes, we'd be very happy to do that. To take you into the observatory itself. We'll even take you into where our 20-inch scope, which we do all of our imaging with, and we can show you some images that we've used there that we have done with that scope. But anyway, Mr. Klimas, thank you so much again for your energy, your knowledge. And we'll just we're gonna have to book you for another presentation. And we also want to thank Coraline for her image that we used as part of our marketing. So that was a great a great image. So come up and take a bow. Take a bow. All right, so thanks again. Before we leave, so the next couple of weeks, this is what's coming up. Next weekend, next Friday, is actually something we've been fortunate to be able to do with some help from the Broome County Arts Council. It's called Exposure. And a film professor from Binghamton University, Toma Nishikawa, is he curates a number of small or short films that have some form of connection to astronomy or night sky images, and so that will be next weekend. That will not be live streamed due to copyright restrictions of the artists. Then the following weekend is, you definitely want to reserve that weekend, because that's our Astrofest. This will actually be our 40th Astrofest. It's a two-day star party with a number of great workshops and presentations, including both on Friday night and Saturday night. We have a scientist who works down at the Space Telescope Institute in Baltimore. They're the people that drive the James Webb Telescope, and so Dr. Kelly Lippo will be talking about what the James Webb scope has provided us so far, and what they hope to provide us. So those will be two great presentations. But we've got a number of other ones. We have Luke Keller, who is a teacher up at Ithaca College, who's flown on the Sophia aircraft. For those that don't know what the Sophia aircraft is, it's a 747 specially outfitted with a telescope inside, and then it gets up to about 50,000 feet. Then the side of the plane opens up, and they take pictures with this telescope, mostly in the infrared. And it's extraordinary when you think about it, to have you got this plane flying, and this big window opens up, and when you do that in a car, you get that kind of sound. Well, you don't get that with that. So he'll talk about that. The weekend after that, we actually have a scientist who works at the New Jersey Institute of Technology, who is a researcher that does research in Antarctica, Gil Jeffers, and he'll be up to talk about his work in Antarctica, specifically looking at space weather. So we've got some great programs coming up. All but next weekend will be on our live stream, but we'd love to, of course, see you up here. So thanks again for coming up. Be careful going home. But again, for those that would like a tour, we'll say started at 9:30, and so meet out here in the lobby, and we'll take you through. So thanks again.